let's get started. Right, we're off to section 2 in the paper. And I believe this was the first question, question 8A. I want to give you all just a 5 minutes, just to work it back and send back your answers on the chat for this particular question. You have to define the shaded regions. Now, this is an inequalities question, which means your answers will have things like more than or less than, or more than or equal to, or less than or equal to in it. So you have to send 3 equations across because there are 3 lines that are bounding the shaded, the shaded region. So I look forward to seeing your answers on the chat. Good luck. All right, so for the red line, let's just get the equations. For the red line, what do you call a vertical line that goes through 2 on the x-axis? So let's at least get that out of the way. What's the equation for that particular line? Right, Rohan, correct. The equation for that, right, Tyrell, is correct. Now, the equation for that would just simply be x is equal to 2, all right? What about a horizontal line? That's the blue line going through 6 on the y-axis. Well, the equation of that would just be y is equal to 6. But the green line, well, he's a slanted line. So we're going to have to find the equation of that line using the, the y equals to mx plus c procedure. So the equation of any straight line is y is equal to mx plus c, where m is your gradient and c is your y-intercept. So let's concentrate on finding the gradient first. To find the gradient, we just need 2 points on the green line. You can choose any 2 points. Look, this point here, he's on the green line, so we could probably just choose him. He looks like 6, 6. And here's another point on the green line that's easy to identify. He is 8, 7. So call him x1, call him y1. This one is x2 and this one is y2. To find the gradient, you'll probably remember this very popular formula, y2 minus y1 divided by x2 minus x1. Let's quickly throw it into the formula. Y2 minus y1, I'm just stealing the values from here, x2 minus x1. So I think we're going to get 1 on 2, better known as 0.5. So your gradient is definitely 0.5. But we still need to find the y-intercept. But I mean, we're trying to save time in the exam. I mean, to find c, we could choose 1 point on the line, substitute it in to find c. But doesn't c represent the y-intercept? That is where it cuts where? The y-axis. Doesn't it cut the y-axis at 3? So let's just save some time. The equation of this line is y is 0.5x plus 3, where 3 is your y-intercept. Now that we have the equation of each line, right? Now it's time to put in the inequalities. Now, just a refresher memory. There are 4 inequalities, right? There's less than or more than, or less than or equal to, or more than or equal to. Anytime it's just less than or more than, you're supposed to have a dashed line to represent the graph. If it's less than or equal to, or more than or equal to, it will be a solid line. What kind of signs are we going to be using today? It's obviously going to be these here, because look at all the graphs that I drew. All the graphs, the red, the blue, and the green, all of them are solid lines. So it will be less than or equal to, or more than or equal to for our answers. So anyway, let's finish up these questions. For the shaded region, right? Let's start with the red equation. The x equal to 2. I need to figure out whether it's more than or less than. Look at the red line. Where is the shaded region? Isn't the shaded region to the right of it? You have to look at, to figure out whether it's more than or less than, you have to look at the shaded region in relation to the graph in question. So since it's to the right, and when you go this way on a graph on the x-axis, doesn't the values get larger? What do you associate with larger? More than. So the first inequality is x is more than or equal to 2. Let's look at the green graph. Not the green graph, the blue graph. Let me get blue here. The blue is y is equal to 6. The blue graph, isn't the shading below the group? That's not a real word. The blue graph, below, when you hear the word below, doesn't the word less than automatically click in your head? So it's less than or equal to. And for the green graph, y is 0.5x plus 3. You notice the shading is above. What do you associate with above? More than, right? These are your final answers for the examiner. Put it in a nice little cloud here. All right. So take down everything that you need to take down, and we will be moving on in about half a minute. Right. So here's part B, right? This particular question. Use the graph in, well, this is obviously a quadratic first of all. And we know quadratics have two normal shapes. So just to refresh everyone's memory, a quadratic has a B, and a C value. This here is the general format of a quadratic. Quadratics, when you draw it, either have this shape, it is called this a maximum or a sad face, or the opposite is a minimum, better known as a smiley face. A is always the item, provided that y is the subject, right? A is the one touching x squared. Anytime A is positive, you always get a smiley face. If A is negative, you always get what? A sad face, right? A frowny face, however you want to view it, right? So in this particular graph, you all notice it's a frowny face, a sad face. And it actually makes sense because look at the quadratic equation. Isn't A in today's question a negative value? It's -2, right? So I'm not too sure if that's going to help us with the rest of the question. I just thought I'd probably mention it, okay? Right. Use the graph to figure out when fx is 0. Now you can think of fx and y as the same exact thing in maths, right? But at least for CXC purposes, okay? Whenever they ask you when fx is equal to 0, that's a real technical way of asking you, where does it cut the x-axis? Okay, so that is what they want to know. To figure out where it cuts the x-axis, we know the x-axis is the horizontal one. Where does the graph cut the x-axis? And they ask us to use the graph to do so. Doesn't it cut the x-axis at 5? And it's looking like, well, 1.5, because it's between 1 and 2. So the answer for this is 1.5 and 5. Okay? Now I'm going to ask you all, in part B, I want you to verify these two answers using calculations. The easiest way to do that is just use the quadratic formula. You all remember the quadratic formula, this one here, minus b plus or minus. This formula, right, actually let me just repeat this. Whenever we use this formula, we get two answers. In the majority of the cases, we will get two answers. Those two answers represent where it cuts the x-axis. Another way of saying where it cuts the x-axis is the solutions to a quadratic. When you solve a quadratic, you're already trying to figure out where it cuts the x-axis, you know. So I want everyone to use this formula and prove to the examiner, and of course yourself too, that when you use this formula, you're going to get back 1.5 and 5. Just don't say you got it. Obviously, exams is right around the corner. So everyone, you know, really try to calculate it and prove to yourself, hey, you're going to get back the 1.5 and 5. Let me know when you are finished. So this helping you substituting the values here. Remember, I have the A, the B, and the C values substituting here. You will get the A, the B, and the C values from up here, from the equation itself. So A is -2, B is +13, and C is -15. So it was minus B here, or the B's replace it with 13. The A is -2, C is -15. Right. Now there are a lot of negative signs here. Now you have to be careful, right? I mean, this part here, I always advise students to work out this part here, right? With the little curvy lines here. To me, it's so easy just to type in this in your calculator and get a value. And if you type in all the signs correct, the calculator is not going to make a mistake once you type in everything correct, right? So it's 13 squared minus, well, underneath the square root sign, I'm just making sure, did you all get 49? That's before I square rooted it. Great. And when you square root 49, you will get what? 7. So you're going to get -3 plus or minus 7 divided by, now a lot of people might make the mistakes here. Remember, the A value is -2. 2 by -2 is -4. So to get your two answers, you have to say -13. 1 second, -13 plus 7 divided by -4. And the other answer, you say -13 minus 7 divided by -4. But if you plan on typing it in straight on the calculator, make sure the top is in brackets. Otherwise, your calculator will not divide both of them by the -4. It will only divide the 7 by the -4. And I guarantee you, if you do this, you will get back 1.5 and 5. I'm pretty sure. Right? But check it for yourself on the calculator. Make sure you see it on the screen itself. Don't ever say, on the day of the exam, I could do that. Now is the time to make sure. Right, so we continue. The question did change. It looked like it didn't change, but this is B part 2. Now, this one here, we want to express it in the form C minus A plus B. Now, this is basically the same thing as H minus A x plus K squared, right? It's the same exact thing. The truth is, but this is called this vertex form. And the examiner could use any 3 letters here. He doesn't have to use A, H, and K, which is the most popular letters. He could use A, B, and C. And remember, there are formulas for vertex form to calculate C, A, and B. The C, A, and B are not the same A, B, and C here. It's different. Remember, there's a formula to calculate the value inside the brackets for the x. The shortcut formula is B divided by 2A. And to calculate the C value is what? 4AC minus B squared divided by 4A. And the A value here, well, it cannot have it. It is -2. But when you have it like this, the examiner already put the negative sign for you. So you just have to replace the A with 2. So that one is easy. Please calculate what goes in the space of B and what goes in the space of C using the shortcut formulas. In the value. So we're going to substitute the A, the C, and the A. Well, 4AC is how much? -2, and C is -15. B squared, so that's 13, and A is -2. Here was 13 divided by 2A. Right, when we work out this one here, 4 by 2 minus by 15 minus. For this one here, I got -49 divided by -8. And I'm getting positive 6.125. Do not round it off, right? Especially in this particular topic. If you get reoccurring decimals, do not round it off. Put the fraction in place of it. For this one here, it's 13 divided by 8 minus, that's not, no, 13 divided by 4 minus, which is minus 3.25. Right, so we put this in this form, you're going to get C 6.125 minus 2, open brackets, x minus 3.25, close bracket squared, right? So this would have been the value of C they were looking for. This is the A and this is the B, which are already H and K. All right, so make sure you see it on your calculators. And to get the maximum point, on the graph, obviously you can just look at the graph, right? But it's going to be hard to identify it. The best way to get the maximum point, now this looks like 3, if you look at the x value, right, it's 3 point something, and the y value is 6 point something, because it's a little higher than 6. But you see, when you put something in vertex form, it is make it super, super easy to identify the exact coordinates of the maximum or minimum point. In this case, we have a maximum point. Remember, all maximum and minimum points will have an x value and a y value. The x value is the opposite of the number in the brackets with the x. So when you look in the brackets, you see negative 3.25. The x value is the opposite of that, which is positive 3.25. And the y value is the value outside, but you don't make him the opposite. You take that value as it is. So you get 6.125, right? And so this would be it here, 3.25 and 6.125. That's the actual maximum point. Right, so take a half a minute, take down anything you need to take down, and we will be moving on. All right, so this one here was a problematic question. So for this triangle, we want to prove something. So we want to actually get this expression from this value. This is a right angle triangle. And you all remember Pythagoras theorem. But there are many different versions, or all of them are the same formula, just different transposed versions of each other. But how much of you all know this one? The hypotenuse squared is equal to side 1 squared plus side 2 squared. Isn't that the most general formula? Or some textbooks will have it like this. C squared is equal to A squared plus B squared, where C is your hypotenuse, the A and B are your regular boring sides who are not the hypotenuse. All we have to do is use this formula, any one of these formulas, in order to get it out, right? I'm going to use this formula over here, right? So let me just write it back on top. So we need real space for this one, right? So according to Pythagoras theorem, C squared is equal to A squared plus B squared, where C is your hypotenuse. So our hypotenuse in this particular question is 3n plus 4. So if we take that 3n plus 4 and you square it, it's equal to the other two sides squared if you decide to add them. So n squared is just n squared plus 3n plus 1. That's this side, but you also have to do what with him? Square him. You have to try to simplify this. And I bet you when you simplify this, you will get this expression. Don't fall for the trick, right? Let me help you out a little bit. 3n plus 4 squared is the same thing as 3n plus 4 multiplied by another 3n plus 4. N squared here is easy. This squared belongs to everybody here. So 3 squared is 9. And then the n plus 1 also gets squared. So that's n plus 1 multiplied by another n plus 1. Take your time, expand the brackets, simplify it. There's a small mistake here. There was supposed to be a squared over here. I believe I mentioned that in the description of the video, right? Expand and simplify, and you will get this expression. Prove it to yourself, and of course, let me know when you finally see it on your end. Right, so when you expanded the first pair of brackets, you got this expression here. The n squared, where he is just n squared, right? We have a 9 here. We'll leave that 9 for last, right? And we're going to expand the n plus 1 by the n plus 1. So you're going to get n squared plus n plus our next n plus 1, right? You all will notice that, like in this case here, couldn't you just add the 12n and the 12n? And this one here is n plus 1 and n plus 1, right? So, well, what you're going to get is 9n squared. 12n plus another 12n is 24n plus 16. We have this n squared here. Now, n plus n is how much? 2n. But when we do that, don't we still have to multiply every one inside here by this 9? So you're going to get 9n squared plus 18n plus 9. Looks about correct? Right? Well, what do we have to do from here? Don't we have to throw everybody on the same side? So if we throw everybody on the same side, right? Let's take our time here. So we just taking everybody and throwing them across. Now, when you throw everybody across, they're going to change signs, right? Now, to make life a little bit easier, right? I'll do a little hack here. When we throw, let me see if this will make sense. I just have to make everybody negative here, right? Right, so it comes like I throw everyone across, right? So what's going to happen? The 9n squared and the 9n squared are going to cancel out each other. You have what? 24n minus 18n, that is 6n, and then you have minus n squared here. 24n minus 18n is 6n minus 9. Now, this is almost the answer we're supposed to get. You notice all these signs are the opposite. But obviously, if I throw everybody on the other side, right, won't everyone's side change and this side will be equal to 0? So we will still get n squared minus 6n plus 9 is equal to 0. Or I can just multiply everyone on this side by minus 1 and multiply everyone on the other side by minus 1. Because in maths, whatever you do to one side, you can do anything in the world once you do it to the other side. Okay? Great. Make sure you take it down. And now you have to find the possible values of n in part B. In other words, they want you to solve this quadratic equation. You think you all could solve that quadratic equation for me? I just showed you all how to solve a quadratic. Remember, it was this formula. Minus b plus or minus, let me write back the formula. The good news is this formula is given to you on the formula sheet, right? And for those who want to use factorization to solve the quadratic, feel free. When the examiner says solve it and doesn't state a method, you can use any method you wish. Right? That's how somebody said I made a mistake. I think I did. So I did make a mistake. It's over here. I forgot 16 minus 9 is how much? 7, right? 16 minus 9 is 7, right? So when you throw everybody on the same side, you'll get minus 7. Thank you for correcting me. All right, so solve this quadratic and let me know what you get, right? I'm gonna write back this formula a little bit neater. All right, so let's see. Well, I have the formula line up here. Let's put B, that's all. Let's make sure we have A, B, and C correct. So A is 1, B is minus 6, and C is minus 7. So B is minus 6. Now remember, the formula says minus B, so we have two negative signs that will come together here. For A is 1, C is minus 7, 1. When you all worked out underneath the square root sign, before you square rooted it, what did you all get? And well, let's confirm. Probably that's where I went wrong. Right, it's 64, right? So that's where, no, it's 64 we're supposed to get. Check it back, because it have a negative here and a negative here. So two negatives will give you a positive. So we're getting 64. So we're going to get positive 6 plus or minus the square root of 64 is 8 divided by 2. So the two answers will be 6 plus 8 divided by 2 and 6 minus 8 also divided by 2. Remember, when you're working this out, make sure the top is in brackets. So I think we're going to get 7 and minus 1. Those look like the two answers. 7 and minus 1. Those are the possible values for n. Quick question. Even though those are two possible answers for n, do you all think the minus 1 is truly valid? The answer is no, because doesn't n look at it. N in the length of this side is n. Have you ever heard about a length being negative? There's no such thing as a negative length. Well, at least for a right angle triangle. So even though there are two possible values for n, there's only one true correct answer, right? I'm guessing in the exam, they will ask you to find the two possible values of n. And then in part C, they will ask you which of those two values is the correct one. And then they'll ask you for a reason. And the reason is you cannot have a negative length. Okay? All right. So sorry about the error there, right? So I miscalculated. All right, so let's move on to the next question. All right. So this one here is a kinematics question. Let's just go through this one straight. The graphs represent a boat sailing in the Caribbean Sea. Find the acceleration between A and B. Now, in this question, the y-axis is in kilometers per hour. So that's your velocity. And the x-axis is in time, right? So I'll put T for time. Whenever you have a velocity time graph and they ask you for the acceleration, they're really asking you to find the gradient of the graph. Now, acceleration usually is measured in meters per second squared, but that is if the distance is in meters and the time is in seconds. But if it's kilometers and hours, then our acceleration will be measured in what? Kilometers per hour squared. All right. But anyway, find the gradient of AB. That is all part A is asking you for. The gradient between A and B. I'm going to give you the 2 points here. A is 0.4, B is 6.10. Good luck. Y1 divided by x2 minus x1, right? So to find the acceleration, I'll put A for acceleration, which is the gradient. It's y2 minus y1 divided by x2 minus x1. Remember, here will be x1, here will be y1. The other point will be x2 and y2. Here will be 10 minus 4 divided by 6 minus 0. I think we're going to get 6 divided by 6, which is 1 kilometers per hour squared. Right. Now, the next part B, they're going to ask us to find the average speed. Let me give you the formula for average speed. Average speed, right, is the total distance divided by the total time. Okay. Now, this is a velocity time graph. If you notice, they did not give us the total distance traveled by the object. In a velocity time graph, to find the total distance, you have to find the area underneath the graph. Now, when you find the area underneath the graph, you will get the distance, but the distance will come out in kilometers, which is good because we want it in kilometers. So to find the area underneath this graph, you're going to have to break up this shape into smaller shapes. So you all notice that you have 4 shapes living inside the shape: a rectangle, a triangle, another rectangle, and a triangle. You think you could find the area of each shape and just add it up, and that will give us the total distance in kilometers. And the total time is 18 hours, because the entire journey, if you look at your x-axis, took 18 hours. So once you get the total distance, divide it by 18, and you get your average speed. Guys, right? So make sure you have the values correct for each shape here, right? The dimensions, we got different color. Well, from here to here would be 6. From here to here would be 4. So that means here would be 6 also, and from here to here would be 6, because they're going from 4 to 10. So that means this total vertical distance is 6, right? You're going from 6 to 14, 14 minus 6, which I can't do in my head for some reason. And from here to here, this long line here, but that's 10. And from here to here is 4, right? So that should help you with the dimensions, though, right? We know here is length by breadth, base by height divided by 2, and so forth. For each section, let's see what I got. Here, for the rectangles are easy. That's length by breadth. So here I got 24. Over here, I got 18, base by height divided by 2. Here's 80, and here's 20. That looks correct, guys? And when you add it up, you got 18 plus 24 plus 80 plus 20. I'm getting 142. My total distance is 142. Somebody said 148 by mistake. Let's check it back, right? It's 142. And the total time is 18. So to get the total, the average speed is 142 divided by 18. So for this one here, I am getting 7.89 kilometers per hour. If anybody else disagrees with the 142, now is the time to tell me, because I do make mistakes, right? So let me know. See? For part C, to convert what we have here between B and C, you all notice the speed is 10, but that 10 is in kilometers per hour. To convert kilometers per hour to meters per second, you have to multiply by 1,000 and then divide by 3,600. So all they want you to do is take the 10, which is in kilometers per hour, multiplied by 1,000 and then divided by 3,600. And the answer will be converted to meters per second. That's all you have to do. I get in 2.78. Anybody else can confirm that? 2.78 meters per second. That's for part C. Right, take down anything you need to take down, and we will be moving on. Let's go. All right, so good luck with this question. you have to get your rules, right? Remember, you have the rules of how to figure out the angles. I believe it was 7 rules in all in circular geometry. When you're sending your answers, obviously be real specific, right? If it's A, you're sending the answer for, say A, right? If it's B, say B. Otherwise, I will not be able to keep track. The first one, they said angle BDF. Now in the exam, they're going to give you 3 letters. BDF, you trace the letters. B to D to F. That's this angle over here, right? For part A. This here would be rule, but when I give you the rules, remember different textbooks will have it in different orders. Remember, this straight line here, this here is a chord. From B to F is a chord, and A to C is a tangent. Now the angle underneath the chord, between the chord and the tangent, is equal to the angle standing on the same chord, but the angle has to be touching the circumference. So in my notes, that particular answer, that particular rule was rule number 7. So that means over here is also 45 degrees. Now in the exam, you have to write back the ruler. You can't say rule number 7. You have to write back the actual full wording for the rule itself. All right, so that's the answer for part A. I'm going to give you some more time for part B. For B, angle FBD. FBD. That's this angle here. You'll notice there's a cyclic quadrilateral. Look at it. From B to D, there's a 1, 2, 3, 4. B to D, D to E, E to F, and back to B is a cyclic quadrilateral. Remember, opposite angles in a cyclic quadrilateral always add up to 180. In my notes, that would have been rule number 4. So if here is 127, how much again do we need to make 180? Well, it's just simply 180 minus 127. 180 minus 127, and we're going to get, well, not roughly, exactly 53 degrees. Right? So opposite angles in a cyclic quadrilateral always add up to 180. The next one, angle C. We got a different color, green. ABD. Where's A? ABD. But this one is super easy. Isn't ABC a straight line? So if here's 45, here's 53, how much again do we need to make 180? Because a straight line is 180. So you just add the 45, the 53, and you just minus it from 180. Now in the exam, you have to show the examiner all that work, you know. You have to put it like this. It will be, you add the what? 53 and the 45, you put it in brackets and you minus it. So you have to show in some working and whatnot. Also, you have to write a sentence. The angle, you know, the total amount of degrees in a straight line is 180, hence ABC is 180 degrees. So you have to write a paragraph for them and show them complete working. All right, so that's letting you know now. If you just state the answers, you will not get it correct. So I'm getting 82 degrees. Right, so we put 82 degrees. The last one, that kind of troublesome one, right? The last one was BFD. BFD, let's see, BFD, that's this angle here. You'll notice that this line is also a chord. This is rule number 7 again. Look at it. The angle between the chord and the tangent is 82. And now you have an angle standing on the chord. Look at it, starting at the beginning of the chord, hitting the circumference and bouncing back to the end of the chord. So here would also be 82 degrees, right? That's rule number 7 in my notes. All right, for those who got any wrong, you think you understand it now a little bit better? The easier way to get this as 82 is all the angles in that triangle is 180. So if I knew here was 53 and here was 45, I gotta just add those two and minus it from 180. Honestly, I didn't see it until somebody pointed it out. All right, so thank you for that shortcut. All right, so we're moving on to the next question. All right, let's go. Bearings. Good luck with this one. Right, these questions usually, in most cases, boil down to the hard sine rule or the hard cosine rule. Right, that was the correction, right? So for this question, it's supposed to be the distance BC because they gave you the distance AC, right? All right, so let's see how this question is going. Let's at least get the diagram going. On a golf course, B is 80 meters from A. So that means you're standing at A. So at A, you kind of pull out your compass there. And it's on a bearing of 105. So that means to walk from A to B, the bearing, which is always measured from north, is 105 degrees and the distance is 80 meters. And C is 120 meters from A. So you're standing at A again on a bearing of 200. So if you're walking from A to C, this angle over here, this red angle is 200 degrees. But once again, bearings are always measured from north in a clockwise direction. And that distance would be 120. And they're asking you to find the distance CB, which is, one of the corrections I had to make. Right? First thing you need to do, you need to find this dashed angle. Well, what's the angle between the blue line and the red line? It should be real easy. It's just a simple subtraction you have to do. If the whole red angle is 200, and from here to here is 105, and you just have to minus the 200 and the 105. Right? 200 minus 105. I'm getting 95. A lot of people are saying 85 by mistake. It's probably a mistake. You're supposed to have 95 degrees over here. So if you draw back this diagram properly, like this, but not properly, but without all the clutter. Here's 80 meters. Here's 120 meters. And the angle in between is 95 degrees. And you want to find this side here. Let me give you the common letters. If here's capital A, over here is common A. Here's capital C, over here is common C, and here will be common B. CB is common A. You are trying to find common A. You try to figure out now whether it's the hard sine rule or the hard cosine rule. Look at your rules. Flip back in your notes. Explain why. Look back in your notes, right? Didn't they give you the length of two sides and the angle in between those two sides? That's a clear case of the hard cosine rule. So if you're trying to find common A, which is CB, it's A squared is equal to B squared plus C squared minus open brackets 2 by B by C cosine capital A close brackets. Okay? So substitute in your values and solve for A. All right, just substituting some values here. Where's B? B is how much? 120 squared plus 80 squared. 2 by 120 by 80 by cosine 95. So you can type in this straight on your calculator, and whatever you get to solve for A, you ultimately square root the answer. I'm working it out on my side here. On this side, I'm getting 2247.3.39 roughly. And then I have to square root that. And when you square root that, you're going to get 149.91 or something, right? I'm going to 2 decimal places, so I'm keeping it at 149.91. And I can update my diagram here. Right? Someone asked if it will work all the time by throwing the whole thing on the calculator straight. Yeah, as far as I know, once you type it in correct on the calculator, it will always work correct. But it's up to you to ensure that you don't make any mistakes when you type it in. All right, so that's it. And make sure you physically see that 149 on your calculator. Don't assume that you could do it on the day of the exam. The next part of the question, they're asking for the bearing of A from B, which means you are standing at B because that comes after the word from, okay? Right, so pretend that you're at point B. B also has a knot, and you want to turn on a bearing to face A. So you stand at knot and you turn clockwise, clockwise, clockwise until you reach that blue line. They want to know the size of that green angle. All right. Let me help you with this one, right? What's going to happen here? You'll remember something called Z angles, alternating angles. For example, if I have a straight line here, a vertical line, then a slanted line and a next vertical line. Now, provided that these two vertical lines are indeed vertical, won't these two angles always be equal? We good with that? That those two angles will be equal due to alternating angle theory. You're going to see that situation here just now. Let me clear up this diagram. I'm going to erase this. Oops, one back. Yeah. Right. So I think I have everything there. Right. Where's one? Right. So tell me something. This line here is a north and this is a south, right? We know from north all the way to south is going to be 180. Think about it, because north is up here and south is directly opposite it. So that's a straight line. So it's 180. You think you all could figure out this black angle here? Use the blue angle to figure out the black angle. If the whole thing is 180 and the blue portion is 105, what's the black portion? Right, Jaden, correct. Anastasia, correct. Dana, correct. Right, you just have to minus it from 180, right? The 105 minus it from 180 and you're going to get 75. Do you all see an alternating angle here? I'm going to trace it slowly. Going up, slanting down, and then going back up. Won't here also be 75? Here's 75. Here has to be 75. All right. We want the size of the green angle. And if we go all the way around, we will get a circle. So if a circle is 360 and this black part here is 75, won't it be super easy to find the green part? You just take the 75 and minus it from 180. And that will be the final answer. It will be 360 minus the 75. 360 minus the 75, and I am getting 285 degrees, right? Taking the black part, which is the 75, minus it from 360, and you're left with the green part, which is what the examiner asked for. So you have to try to find angle ABC. ABC. That's from this top here. We slide down to this corner and then we walk all the way to C on the ground. Now, this is going to be a right angle. But when even though it's a 3D diagram, that green triangle is going to be a right angle triangle. And they want the angle ABC. That's this angle here, between the slanted line and the ground. So good luck with that one. Feel free to send your answers across. You ever notice that you have the lengths of some parts, right? Like A, C, from A to C, everybody agree that's 3? Because if this side is 3, then this dashed line, which is on the opposite side of the box, is also 3. But we don't have the length of CB. Now, don't get me wrong, from here to here is 10 meters, because if here is 10, then here is 10, and here is 10. And what's the distance from here to here? Let me put a letter, I'll call it D. What's the distance from C to D? C to D looks like how much meters? 5, right? Definitely 5 meters. So, and the underneath of a box is a rectangle. So here's a right angle. Couldn't you use Pythagoras theorem to find the length of CB? Because here's 5 meters and here's 10 meters. Now, it's kind of hard to imagine because it's a 3D diagram, but from C to D to B, back up to C is a right angle triangle, where this green line is the hypotenuse. So to find the length of CB, you could say 5 squared plus 10 squared, and you square root that, because we're trying to find the hypotenuse. So let's get the length of CB quickly. 5 squared plus 10 squared, and you square root that answer. So I am getting, anybody can agree with this, 11.18 meters. Let's double check it. So here's 11.18. Couldn't we find this angle using tan now? Because if we're standing here, the 3 is opposite and the 11.18 is the adjacent, right? So that is definitely tan, because tan is opposite over adjacent. So tan theta is opposite divided by adjacent. The opposite side is 3, the adjacent is 11.18. Divide it and tan inverse your answer, and that will be the end of the question. I am getting roughly around 15.00 degrees, which is 15 degrees. Double check it. Once again, everyone is sleepy, and so am I, so I could make mistakes. And this is the last question we're doing for the night.